Okay, section 2.3, solving linear equations. So using the addition and multiplication properties of equality, we've actually been doing a little bit of that in section 2.2. But we're going to expand that just a little bit. So in general, solving a linear equation, first of all, you have to understand that a linear equation is something where all of the variables are only raised to the power of 1. So any variable that you have in there can only be raised by the power of 1 and cannot be multiplied by each other. So you can't have something xy. You can't have something where it's multiplied with the x's and the y's are multiplied together. The general idea is when you're solving a linear equation, you're going to look to do the order of operations in reverse. So instead of doing grouping symbols, exponents, multiplication, division, addition, subtraction, you're going to look to do that type of process in reverse. So in general, you're going to look to do your adding and subtracting first, then you're going to undo your multiplication and division, then you would undo exponents and then grouping symbols if necessary. Sometimes it makes more sense still to simplify first. Okay, so let's do some examples. So in this case, we've got 4 times quantity, 2x minus 3, and then plus 7 equals 3x plus 5. So in general, what we want to do is we want to simplify the left-hand side first. So we're going to simplify it. We want to remove the grouping symbols if possible. So we are going to distribute first. So let's distribute the 4 into the 2x and the negative 3. We're going to get rid of those grouping symbols. So 4 times 2x is 8x, 4 times negative 3 is minus 12, and then plus 7 equals 3x plus 5. Combine like terms. Whatever like terms we can combine, we're going to do that. So this is all still the simplification process before we even start to solve the problem itself. So 8x is by itself. There's no other x's on the left, but I do have a negative 12 and a plus 7. So negative 12 is 12 to the left, coming back 7 to the right, only puts us at minus 5. There is nothing to simplify on the right because there's no like terms. Okay. Adding and subtracting, combining like terms, we want to get all of the x's to the left. And again, remember, I try to do the smallest value of x, the smallest coefficient. So I'm going to get rid of the 3x, which is right now a positive 3x, because there's no minus sign out in front. So we want to subtract 3x on both sides. 8x minus 3x on the left is 5x. Bring down the minus 5. Equals 3x minus 3x is 0, bring down the plus 5. You don't have to write the plus out in front if it's the first thing that's left over on one side or the other. You can, doesn't matter if you do, but you don't have to. Now, order of operations in reverse. The first thing we're going to do is we're going to add or subtract whatever we can to get it away from the x. So in this case, I've got a 5x minus 5. The first 5 here is being multiplied. The second 5 is being subtracted. So I'm going to get rid of the subtraction first by doing the opposite, which is adding 5 to both sides. When I add 5, I'm going to get 5x plus 0, which is 5x, equals 10. And then to finish solving, we're going to divide, because that's 5 times x, so now we're going to divide both sides by 5. 5 divided by 5 is 1, so that gives me x. 10 divided by 5 is 2. X equals 2 is the solution to that linear equation. Okay, example number 2. Let's get a little more space. There we go. Now we're going to have 8 times the quantity, 2 minus t, equals negative 5t. So again, simplify first. We need to remove all the parentheses if possible. So we're going to distribute 8 times 2, 8 times negative t. So 8 times 2 is 16. 8 times minus t is minus 8t, equals negative 5t. All right, so you got to be careful here. Which is smaller, negative 8t or negative 5t? Thinking about your number line, negative 8 is further to the left than negative 5. So we're actually going to try and add the 8t to both sides of this equation. Because that's the opposite of subtracting 8t. So then on the left-hand side, I'll have 16 minus 8t plus 8t is 0. That went away. And then I have minus 5t and plus 8t on the right-hand side. So I went left 5t, back to the right 8t, which should put me at positive 3t. Now I've got just a t, which is left over on the right-hand side, but it's multiplied by a 3. In order to undo the multiplication, we divide both sides by 3. 3 divided by 3 is 1, so that leaves me with just t. 16 over 3 does not divide evenly. 3 goes into 15 evenly and 18 evenly, but not 16. So we're going to just leave this 16 thirds. There's absolutely nothing wrong with that. So there's the solution to the second one. That one's going to be a little bit tougher if you try and plug it back in to prove, but it does work. If you plug 16 thirds into both t's on both sides of the equation, you actually do get a true statement. Okay, well that was an answer that gave us a fraction. What if the original problem has a fraction in it? So we want to solve x over 2 minus 1 equals 2/3 x minus 3. So if you're like most people, fractions are not the easiest things to deal with, and I would rather not try to solve an equation that has these kind of fractions if possible. So we can actually do a process where we can get rid of all the fractions in this problem at one time. And this is probably the best method to do this problem. The idea is, look at your fractions. Look at your denominators. I have a 2 and I have a 3 in my denominators. What I can do is I can find a common denominator between those two things, and then whatever that common denominator is, I can multiply every single term by that denominator, and we're going to get rid of all these fractions at once, and then we'll have a much easier problem, a linear equation to solve. So the common denominator between 2 and 3 in this case, the easiest one is 6, because 2 and 3 both go evenly into 6. So what I can do is I can multiply the entire equation by 6, which means I distribute the 6 to here, to here, to here, and to there. You gotta multiply the 6 by every single term. So I'm going to get rid of all those lines. Oops, got rid of my 6. So if I do the first one, let's see if I can do this. If I multiply 6 times x over 2, remember that this can be written as 6 over 1 if we need it to be. So if multiplying straight across the top, straight across the bottom, we're going to get 6x over 2. I don't need to use the 6 over 1 to multiply it by the minus 1. That's just 6 times minus 1, which is minus 6, equals. Now I got to take and multiply the 6 over 1 times the 2/3 x. So 6 over 1 times 2/3. Again, multiply straight across the top, straight across the bottom. You're going to get 12 over 3x. And then for the last one, again, I don't need, because it's not negative 3 is not a fraction, I don't need the over 1. So it's just 6 times negative 3, which in this case is negative 18. And you're probably thinking to yourself, well, I thought you said you're going to get rid of the fractions. We are, because now we can simplify the two fractions, because 6 divided by 2 in the first fraction is 3, so I get 3x minus 6. On the right-hand side of the equation, I've got 12 divided by 3, which is 4, and then the x, minus 18. So I have gotten rid of all the fractions, and this now becomes a much simpler linear equation to solve. I have no like terms to combine on the left and right, so now I can get all the x's to one side or the other. So I'm going to take the smaller one, which is the 3x, and get rid of it by subtracting 3x on both sides. That would leave me with negative 6 on the left. On the right-hand side, 4x minus 3x is x. Don't forget to bring down the minus 18. In order now to solve for x, I need to do the opposite of subtracting 18, which is to add 18 on both sides of the equal sign. On the left-hand side, I went negative 6, and then I went positive 18, which is going to put me at positive 12. On the right-hand side, x minus 18 plus 18 just leaves us with x. So the solution is that x equals 12. Okay, a little bit longer of a process, but I think well worth it to try and get rid of all those fractions, because otherwise you're going to have to get a bunch of common denominators, combining a bunch of fractions on the left and the right-hand side, and then the algebra gets pretty tricky. So I think that's probably the best option. Okay, and that pretty much will work anytime we have fractions. So let's do another one where we have fractions. So we're going to solve 2 times parentheses a plus 3, all divided by 3, equals 6a plus 2. Now I don't have a whole bunch of fractions, but I do have one fraction. So the idea is, let's get rid of that fraction. In order to get rid of the fraction, I need to multiply both sides by the common denominator. Well, there's only one denominator. It happens to be 3. So if I multiply 3 on the left, remember you can write that as 3 over 1 if you have to. And on the right-hand side, I'm also going to multiply by 3. I got to remember, however, the entire right-hand side has to be multiplied by 3. So I'm going to put a parentheses there, just to remind myself. And over here, I will make that over 1 just to make it easier. This is a good time to use the cross cancellation. What I can see on the left is that I've got a 3 and a 3. That goes away. So what that leaves me with is the 2a plus 3. On the right-hand side, I have to remember to distribute the 3 to both terms. So 3 times 6a is 18a. 3 times 2 is 6. I'm going to distribute on the left 2a plus 6 equals 18a plus 6. So I'm going to go ahead and get all of my a's to one side. I'm going to take the smaller amount, which is the 2a, and subtract it, because right now it's plus. So that's going to give me 2a minus 2a is 0, bring down the 6. 18a minus 2a is 16a, bring down the 6. All my a's are combined on one side of the equal sign, so now let's go ahead and do the reverse order of operations. I want to subtract 6 on both sides. 6 minus 6 on the left is 0. That's okay to have. And then 16a plus 6 minus 6 is 16a. A lot of people tend to get confused at this point. It's still the same process. I've got 0 equals 16a. Well, in order for that to be true, I'm still going to have to divide both sides by whatever's attached to the a. On the right-hand side, I get a. On the left-hand side, we get 0 divided by 16. Remember that 0 in the numerator is fine, because I can have nothing, divide it as many ways as I want, and I still have nothing. So in order for this equation, the original equation, to have been true, a would have had to have been 0. And that is the solution to that equation. Again, go ahead and go back to the beginning, plug it in, and you would see that you actually end up with, I believe, 2 equals 2 if you plug it all back in. Okay? So the process works just as well with decimals. We're not going to do an example of that. You might come across a decimal in your homework. I want to do some special cases of what could happen. So our next example is going to be -2 times the quantity of x minus 5 plus 10 equals -3 times the quantity x plus 2 plus x. All right, let's see what happens here. Again, simplify first. Get rid of the parentheses if possible. So we'll distribute the -2 into its parentheses and the -3 into its parentheses. The first one will give us -2x plus 10, and then don't forget the other plus 10. The right side is going to give us -3x minus 6 when you distribute the -3 in there, plus x. Let's combine like terms. So the left-hand side, -2x, we've got these 10s to add together, so that'll be plus 20. On the right-hand side, we've got a -3x and a plus x added together will give us a -2x, and then a minus 6 to bring down. So now if I take the smaller, well, I don't really have a smaller x's, they're both -2x, so I want to go ahead and add 2x to both sides of this equal sign. On the left-hand side, I get -2x plus 2x, which is 0. I bring down the 20. On the right-hand side, I get -2x plus 2x, which is also 0, equals -6. All my x's went away, and I get a statement that says that 20 equals -6. Well, that's obviously not true. 20 does not equal -6. So after going through all the algebra in order to try and solve this, I got a false statement, something which cannot possibly be true. If that's the case, what that indicates is that there is no solution to this equation because it gave me a false statement at the end. That means there is no value of x that I can plug back into the original equation that will make the equation true. This has no solution. And just so that you know, there is a symbol that we use for no solution, and I want to make sure you guys understand this. The symbol looks like that. Some of you guys probably write your zeros that way. If you write a 0 that way, that actually indicates in math that there is no solution. So please try to refrain from writing your zeros with the slash through it because it might be misconstrued as a problem that has no solution. That symbol is actually what is called the null set. It means that there is no solution. It's the empty set. Okay, one more example. So we'll have 3 times the quantity x minus 4 equals 3x minus 12. So once again, we'll go ahead and distribute on the left-hand side to get rid of the parentheses, which would give us 3x minus 12 equals 3x minus 12. Okay, well, we can still go through the same process. You might be able to see what's going to happen here. If I combine all my x's, I can subtract 3x on both sides, and I end up with, on the left-hand side, negative 12, and on the right-hand side, negative 12. So this one, again, I've gotten rid of all the x's, gives me a true statement because negative 12 certainly does equal itself. It equals negative 12. This resulted in a true statement. Anytime you get something like this and it results in a true statement, it means that it doesn't make any difference what value of x I plug into the original equation. Every single time it will work. So that means the solution to this is what is called the identity solution, by the way. The solution to this is all real numbers. And a shorthand notation for that is just a capital R with an extra line through it. That is the solution, the notation for all real numbers. All right, so in general, when we're solving these equations, these linear equations, you have the idea to try and solve for the value of x, and you'll come up with a value that makes the statement true. There are possibilities, like the last couple, where you might go through the process and you get a false statement at the end. If that's the case, there's no solution. Or you might get a true statement like the one that we just did here, in which case there is all real numbers. It makes no difference what the number is you plug in for x. Everything will possibly work. Okay, so that is section 2.3. You should have enough to get started on any homework that you guys have been assigned.